For the third video segment for the fan test stand lab session, we're going to go over the handout, the data sheet, and the analysis, and also the equations. And I am thinking that we won't need to do a separate video or handout for the analysis. So please bear with me, this might be a little bit lengthy, and I'm going to jump back and forth between the pages on the handout. So page 1, and again you will receive a PDF of this all filled in. So you'll have all the data, but you're going to see a blank data sheet today. So we just talked briefly about the procedure, the analysis. I'll talk about a little bit more detail later on in this video. And then we start equations and notes at the bottom of the first page. But I'm going to jump ahead to what the data sheet looks like, because that is going to make everything else make more sense for you. And thanks again, Adrian, for the use of your clipboard. Okay, so you're going to have 6 different copies of this data sheet. We'll probably just have the barometric pressure and the temperatures on the first one. You will need those to calculate the density of the air. That's going to be part of your calculation. And I think by now you already have that equation that was in the last week's handout also, okay? So you've got that. So you'll have the barometric pressure in inches of mercury and then the temperatures. The fan or fan combination under test, so this will be one of 6 cases. It will be the 10 horsepower fan slow, 10 horsepower fan fast, single 5 horsepower fan slow and then fast, and then 2 5 horsepower fans in series, both slow and fast. So for each of those there will be a separate data sheet. And then you can see that we're going to record 8 points for each of these test configurations. We're going to list the restrictions that we used. You saw those in the last video, M1, B3 plus M2, etc. That just lets us know where we are in the test, and that information comes from the laminated sheet that's on the table I showed you. And then the data that we are going to record is going to be over to the right here. So the first is going to be the delta P pressure, the static pressure at the inlet section of the fan test stand. We're going to use that to calculate Q according to an equation that we'll go over shortly. Then the next column is the actual pressure developed by the fan across the restriction box. So that's P sub S, and we're going to use that to plot P directly in our fan curve, P versus Q. And we'll also use this pressure to calculate fan power, the aerodynamic power produced by the fan. Talk about that in just a minute. Then we have a column for volts and amps and power factor. It's a 3-phase fan, and the variable frequency drive basically lowers the voltage to get the fan to run at lower numbers. So this will be, you'll see what these numbers range at. And then the power factor is dimensionless. It basically relates to the capacitive response of the fan compared to the inductive response if you've had mind power. And you'll multiply these together along with the square root of 3 to get the electrical power consumption by the fan. And then the RPM, you saw how we measured that with the laser tachometer in the last video. That usually doesn't vary much. So what we typically do is we will adjust the speed setting to the specified level. We'll find out what the RPM is. We'll write it here. And then at the end of the test, we'll just verify that it hasn't changed. Okay? So again, you will receive 6 of these already filled out. You'll have all of the information there for each of the 6 cases that we talked about. So now I'm going to go back to the first page, and we will talk about the analysis of that data. Okay, so again, you will have the barometric pressure and the temperature, so calculate the density in pounds per cubic foot. You're going to need that. And then for each of the 6 combinations, you're going to plot P sub S, that's the static pressure developed by the fan. That's just read that directly off the data sheet. Q is the flow rate. You're going to calculate that based on an equation which is on the next sheet. The electrical power is also on an equation on the next sheet, as is the fan power and the efficiency. So those are all described below, but you want to plot those. You'll have your horizontal axis will be Q, your vertical axis on the left will be P sub S, and then the other powers will be on the right-hand axis, okay? So it says down here, if you can do it all on one plot, great. Some spreadsheets won't let you do that, but make those plots and comment on the results. Then for the two single fan configurations, so this will be the 10 horsepower fan operating at low and high speeds, and then the single 5 horsepower fan operating at low and high speeds. Determine if the fan laws apply by scaling up the low speed results and compare those to the measured high speed results. So you'll see what those fan laws are also on the next page. Comment on those results. And then for the two 5 horsepower fans in series, so the discharge from the first fan is going into the inlet of the second fan. Compare the theoretical results expected from the single, let's see, sorry, lost my place here. So compare those results to what you would expect based on the single fan. In other words, does the flow rate Q remain the same with the pressure doubling, or is it different from that? Okay, so then the bottom of this first page of the handout, it just lists that P sub S is the static pressure developed by the fan. Again, you're going to plot that directly versus Q, which you will calculate. So Q, the flow rate, is calculated from the delta P measurement, which you recorded, and it's an empirically derived relationship. So I'm going to change the page, and the top of the second page of the handout is that equation. Okay. So to find out what the flow rate is based on the delta P measurement at the inlet, we have Q equals 840 times D squared times the square root of the quantity delta P over W. And I hope you guys have seen this notation for square root before. This is an older handout and didn't have access to a square root symbol, okay? So D is the diameter of the duct, that's 1.5 feet. Delta P is the static pressure difference that we measured, inches of water. W is the air density in pounds per cubic foot, and you've already got other sources of that equation, so I did not include that here. And then Q will be in CFM, okay? So this equation is from British Standard 848, and that standard also includes dimensions for fabricating the test stand. And again, this is empirically derived, so somebody spent their PhD, or many PhDs were sacrificed in order to develop this empirical relationship. So again, delta P we measure, density of air is going to be a constant, D squared is a constant, and you can find out what the flow rate Q is based on what that delta P is with those given restrictions in the box. Okay, moving down this sheet, again, this is the second page of the handout. You can calculate two types of power from the measured values. The electrical power consumed by the fan is volts times amps times the square root of 3 times power factor. And volts, amps, and power factor will be recorded on the data sheet, so very straightforward calculation, okay? And those of you who have had mine power or some kind of introductory electrical engineering class, hopefully this is familiar to you. Then the aerodynamic power generated by the fan itself, the fan power, is the static pressure times the flow rate times the conversion factor 0.117. So P sub S is in inches of water that you'll write down. Q is in CFM that you'll calculate up here. And then 0.117. And so you'll get a fan power, and that is going to be in watts. Okay? So this will also be in watts. So then the efficiency is simply the fan power divided by the electrical power. And that's going to be some number less than 1. Okay? Probably quite a bit less than 1 for the most part. Then below that, we have notes on what the fan laws are. So if you have a given fan at constant air density, then for different rotational speeds N1 and N2, the flow rate Q is directly proportional to the speed. So Q2 equals Q1 times the quantity N2 over N1. And again, Q is in CFM and N is in RPM. So Q you're going to calculate from this equation. RPM is measured. So you want to look at this relationship from the two cases of single fans so look at the two cases of the 10 horsepower fan, see if this holds true, and the two cases for the single 5 horsepower fan, again, low speed and higher speed. Same thing with the pressure, that is a squared relationship. So P2 equals P1 times the quantity N2 over N1 squared. So see if that holds, again, for the two single fan configurations, 10 horsepower and single 5 horsepower. And then look at the fan power as a cubic relationship. So power 2 equals power 1 times the RPM ratio raised to the third power. And in this case, fan power refers to the aerodynamic power that you calculate here and not to the electrical power, okay? So again, you want to see if these laws hold based on the low speed and high speed cases of the 10 horsepower fan and the single 5 horsepower fan. And then finally, when fans are connected in series, the static pressure should be doubled, but Q should remain the same. And it's a vice versa situation when they're connected in parallel. The pressure should remain the same and Q should double. We didn't connect them in parallel, but we did connect the two 5 horsepower fans in series. So see if this law holds also. Okay, so fairly lengthy explanation here, but hopefully this explains the data sheet and the analysis to you. So please don't hesitate to contact any of us if you have any questions. And I think after this third segment, we're ready to take some measurements.